And this is the PowerPoint with by far the best graphics. So you have this B. And they're giving you the velocity graph. And that's what the B is doing. But this is, ready? This is a review. We did this. You just have to make a connection. Because what are we saying? How far did the B go? Well, it's the area under the velocity curve. The area under the velocity curve tells you the difference in position. So the B traveled 700 feet. But how far did the B get? Only 100 feet. Okay? So what's happening? The bee is traveling away from the hive, then back to it, then away from it, then back to it. But he didn't get all the way back, or she didn't get all the way back yet. I don't think it's the queen bee because they wouldn't be doing all the work. So the bee didn't get all the way back to the hive yet. So it's the difference between whether you take the total area or the absolute value. And there was a problem we did in the book where they had this symmetric curve. And when they took the absolute value, they just reflected everything above the x-axis. That's what we're doing here. So displacement is the area under the curve from A to B, under the velocity curve, where the area below the x-axis works against the area above the x-axis. That's displacement. That's where the bee was 100 feet away from the hive. Versus total area. And the distance traveled is the absolute value of that. So you have to understand the problem in context, because you know that if you get a multiple choice question, then both answers would be there. They're not going to give you, only one of those choices. You get a multiple choice, you have to read the problem. So here's a different velocity graph. But again, what is this? This is how we learned anti-differentiation in the beginning of chapter 5, when they gave us curves where we could calculate the area by geometry. We don't have, well, we can figure out the function. It's not that complicated. It's a three-piece linear function. But if we just calculate this area by using geometry, there's the displacement. Because there's more area below the x-axis than above by a magnitude of 1. Distance traveled, you would take this area down here and reflect it over the x-axis. Yeah, that's what you would do. You don't have to do it. You just add them up. The negatives don't work against the positives for total distance when you take the area of the velocity curve. Now, what about position? Does this make sense to you, the position? Something. What about that graph makes sense to you? One thing on that graph. William. Yeah. Look, you're here, ready? At the point 4, 0. At 4, 0, the area above the curve corresponded to the area below the curve. That's why you're at 0. And to the right of that, what Liam's talking about, when you're below the axis, that's when, after 4, the area under the velocity curve was greater below the axis. Yes? What else makes sense? Well, the position graph's quadratic, and the derivative is linear. That makes sense. Now, we're going to give you, we already did give it to you. In Canvas, in the resources folder, is or two documents that outline all the questions over the last 6 years, not counting last year, that were on the AP test. You will not be ambushed by a question, depending on what your level of preparation is. Like if you embrace that information, you're just going to get questions that you've gotten before with different numbers. And if you ignore that, oh, you know what, I was busy, I was studying for this, I didn't look at that, then you're going to get ambushed because you don't know what to expect. We're going to show you the questions that occur in a pattern. What question to expect on the FRQ. See, here's the point. I will take ownership of the FRQs. You have to take ownership of the multiple choice. That's why you've been getting multiple choice questions as exit tickets. And once we get to the spring, you're getting FRQs in this room, okay, that will correlate with the anticipated FRQs. But this goes back to when we talked about the big derivative puzzle. Like, okay, I have to make sure that I understand, like, what's happening. Here, this graph and the position is going up from 0 to 2. And from 0 to 2, the velocity is positive. Yeah, I'm not really crazy about this. I think this is more confusing than helpful. They're just telling you where this comes from. So position is the antiderivative of velocity. Just means the area under the velocity curve. That's how they got it. The area of the velocity curve tells you the position, the change in position. Okay? So how about this question? That is a calculator question. Okay? If we are in, we don't have second hands on this clock, but you would get 3 minutes to answer this question in May. If you need more than half that, that's not good. Begin. I mean, we could do the problem without a calculator just for fun. Yes. So what do you got? Cosine mu, where mu is 1 over pi times t. So we need d mu, which would be 1 over pi dt. But if I multiply by 1 over pi, did this backwards, then this should be 6 times pi out front. Pi times 1 over pi. We're doing this by substitution, but it's ready. That's just for fun. You're going to do the problem with the calculator. So, what answer do we have? None of them? You're literally just typing this on the Math 9. Jamie. D? B. Yeah, 725. Yeah, we got some correct answers there. Just type it in Y1. You know, anti-differentiate it from 0 to 60. Make sure you're in radian mode. You're going to get B. But you could do this problem without a calculator. It would just be a little time consuming. So, example 2. And I am here So here's example 1. This is a velocity function, which is what? ds. They're saying position is s. You want the derivative of position in respect to time, which is the velocity. And it's giving you, ready? There's the velocity graph, and it's moving horizontally from 0 to 5. Then what? Well, if I put 0 in here, 0 in here, has an initial velocity of -8, because you have -8 over 1. The initial velocity is -8. So they need more information in example 2. In example 2, they said, okay, the initial position at time 0, which they didn't give you in example 1, is 9. So what's the particle's position at 1 and 5 seconds? So we go over here, and we build the H chart. Here's the velocity curve. Yes, and I just rewrote that with a negative exponent. Then in the H chart, I wrote this. That was the given information. And my velocity is s prime. It's a derivative of position. So to anti-differentiate this thing, ready? Power rule in reverse. And what? This is mu, where mu is t plus 1. So d mu is a 1. We could just do this without having to apply the chain rule, because the derivative inside is a 1. You're using the chain rule, but you're getting a 1. So you get this plus the constant. So the constant is for indefinite integration, if we're not given the limits. We know, ready, that at time 0, we were at 9. So for position, we put a 0 in here. You get a 0. 0 plus 1 is 1 in the denominator. 8 over 1 is 8. But you're at 9, so we have to add 1 to that. We subtract 1 from the left or add 1 to the right. Is that logical? So this is the position, because we have quantified the constant. Now what? Well, what's displacement? Displacement is just anti-differentiate this thing. Oh, but you didn't write the constant. Well, the constant's is going to subtract every time. Here's the work. Ready? When we put from 0 to 5, put 5 in here for t, subtract, put 0 in there. The constant's a 1. It's going to subtract that every time. So when I go over here, there's the 1 for the position. But you're going to get 35 because I didn't put the 1 up here on the math 9 because the 1 subtract out. Then if we graph it, what's happening? We go to parametric mode and we make the y value a variable. So it'll leave a trail. So we can see what happened. We know this thing started at point 9. That was the position. It went left and then right. So if we take an example 3, the absolute value of this thing, instead of this part to the left working against the part from the right, you add them all up. Does that make sense? The particle ended up 35 units to the right of where it began. But it started to go left first, so it traveled more than 35 units. So you're going to problem 1. I'm going to pause the video. For problem 1, ready? The velocity is 5 cosine t. They tell you the initial position is at 3. So here is the H chart. You need that H chart, Ben? Really? You need it. Not somewhat. You need it. So now what? That's the derivative position. You anti-differentiate this thing. Cosine's a derivative of sine. So you get 5 sine t. Except the sine is your y value. At 0, 5 times 0 is 0. And you're not at the position 0, 0. You're at 0, 3. So that is the value of the constant. For displacement, what happened? Well, it's the cosine. So if you go from 0 to 2 pi, you just went around the circle. This number would be a 0. Displacement 0. What'd you get? You got that scientific notation because you overloaded the calculator. You have to be able to read that that's a 0. And then what? The absolute value of this, well, you don't have the 3 there. You can put the 3 there, but it's going to subtract to 0. So the absolute value, this is 20. So you traveled 20 units, but you got back where you started. And here is the work without a calculator. With the 3, and you can see how the 3 right here is going to subtract to 0. Right? 3 subtracts to 0. This is displacement. And then what did I do over here? I said, let's look at one of the trips, one quadrant from 0 to pi over 2, because the cosine is positive from 0 to pi over 2. And then multiply that by 4 trips. Because I'm going to do this without a calculator. I'm not going to get involved. I don't want to get involved with the absolute value. I'm just going to say, take the 1/4 of the trip that I know is going to give me a positive answer, quadrant 1, and expand that by a factor of 4. Okay? So all of this in the alpha lesson was a review. This goes back to